Okay, so this is exercise 2.8 and what we're looking at here is the polar form of a complex number. Now the polar form of a complex number, if z equals x plus yi, the polar form is r bracket cos theta plus I sin theta. Now let me explain what each part means. The r value is the modulus, so the r value is getting the length of the complex number, which is the real part squared plus the imaginary coefficient squared. Okay, the modulus is the distance from the origin at the point represented the complex number diagram. We've done that before. The argument theta is the angle between the positive real axis and the line from the origin to the complex number itself. So what we're going to do here is we're going to put these formula into action, starting off with question 4, followed by question 6, followed by 11, and then followed by 15. Okay, and let's check out question, and we'll do question 3 as well. Okay, so question 3 is 2 plus 2 root 3i. Okay, so it's 2 plus 2 root 3i. Now, first thing to note about this question is that when you draw it on the plane, okay, and this is drawn on the plane, it's going to be 2 across, 2 root 3 up. Okay, so it's going to be up here somewhere. Okay, so then when you draw your axis here, you're going to get it's 2 root 3 up and 2 across. So what I need to do here is I need to find the length r. Okay, so to find r, what I do is I get the real number squared, so it's going to be using this formula here, the square root of the real number squared, so it's going to be 2 squared plus imaginary squared, which is going to be 2 root 3 squared, and then on the other side, then we're going to find out what the r value is, and the r value is going to be 4. Okay, so now we know that r equals 4. Next thing we've got to do is find out the angle theta. So tan theta ends up to be 2 root 3 all over 2. So tan theta, so I have to find out what theta is. So theta is tan inverse 2 root 3 all over 2. So find out what tan inverse is. So we're going to go shift tan inverse 2 root 3 and divide that by 2. Find out it's 60 degrees. Okay, so theta equals 60 degrees. So my r value, or my z value, is the same thing as 4 brackets cos theta, so it's going to be cos 60, and then plus I sin theta, which is I sin 60. Okay, and that's the first question done. Now let's move on from there. So on the next one, what we're looking at here is we're looking at part 4, which is thus I. Okay, so the complex number this time is 0 plus 1i. 1i, 0 on this axis, 1i up. Now this here is a 90-degree rotation, so the angle is 90 degrees. Okay, now the angle is 90 degrees and the length is 1, because it's not, it doesn't even make a triangle, the length is just simply 1. So r equals 1, theta equals 90 degrees. Once again, using this formula here, we're going to get z equals 1 times cos 90 plus I sin 90, which is so simply cos 90 plus I sin 90. Okay, that's the answer to question number 4. And let's continue on. The next question after that we're going to do is question 6. Okay, so question 6 is 1 minus root 3i. Just double check that. 1 minus root 3i. Now, 1 is 1 across, and then minus root 3 down, so it's here. So what we can see here, guys, is that it's this angle here. Okay? So what we have to find out first is what is the R value of this complex number. What is the length of this? Okay, so what we're going to do is once again put it into real plus imaginary squared. So it's going to be 1 squared plus minus root 3 squared. Put that into the calculator. So we're going to get square root of 1 squared plus minus root 3 squared. And we get here is R equals 2. So R equals 2. Now, next thing to remember here is about the angle. The angle we're looking for goes all the way around because it's going from the positive part of the x-axis directly around. So we have to remember Anto stole the car. A-S-T-C. And there's different rules for different quadrants, okay? So the first quadrant, there's no rule. Second quadrant, it's 180 minus your reference angle. Third quadrant is 180 plus your reference angle. And finally, the fourth quadrant is 360 minus your reference angle. Okay? So, what we're going to do here is, we know that the reference angle here, it's going to be root 3 down and 1 across. So the reference angle R, tan R, equals root 3 over 1. So tan inverse root 3, and find out what R is. So shift tan inverse root 3. Find out what R equals. R equals 60. Therefore, theta is 360 minus 60, so this is 300 degrees right here. So theta equals 300 degrees. R equals 2. This means my polar number is going to be 2 times, use your formula here, cos 300. 2 cos 300 plus I sine 300. Okay, so that's the answer to question 6. So, moving on. Wait a second, don't worry about those. So, what we're going to do is we're on to the next part now. And the next question is going to be number 11. So, number 11 is minus 4 root 3. Minus 4 root 3 I. That's what Z is. So minus 4 is left 4, minus 4 root 3 down is probably down here somewhere. So what we have is an angle in the third quadrant. Okay. Now we got to find out the R value first. And once again, as you say about the R value, it's going to be 4 on. We have to find out the R value. Okay. You do Pythagoras' theorem, but what we like to do instead is we've got to find out that modulus. Modulus is going to be minus 4 squared plus minus 4 root 3 squared. So go to the calculator. Square root sign. Then we're going to use minus 4 root 3 squared. And then we're just going to use minus 4 squared for the other part. And put that in, and we get 8. Okay, so this one here is 8. So R equals 8. Now we got to find out the reference angle. The reference angle R. Okay, because it's third quadrant. So tan R equals 4 root 3 over 4. So tan inverse 4 root 3 over 4. What we get here is 60 degrees. R equals 60 degrees. Now remember that if that's 60, this part here is 180. And the third one says 180 plus 60. So the full angle theta is going to be 240. Okay, so that's 240 right there. Now what we gotta do next is z equals r cos theta plus I sin theta. It's the generic equation, so we're going to say z equals 8 into cos 240 plus I sin 240. Okay, so that's number 11. Now once we've done number 11, we're going to try number 15. So let's have a look at number 15 now. Number 15 is 4 over minus root 3 plus I. So 4 over minus root 3 plus I. Now the problem with this one is it's not in the usual complex number form. It has to be in the form x plus yi, as we can see here. So what I need to do is need to multiply the top and bottom by the modulus, which is minus root 3 minus I minus root 3 minus I. So I have to multiply the top and bottom by this. So I'm going to get minus 4 root 3 minus 4i, all divided by minus root 3 by minus root 3 is 3. Then we're going to get plus root 3i minus root 3i minus I squared. They cancel. The minus I squared comes plus 1, which makes 4 on the bottom. Divide 4 in, and I'm going to get minus root 3 minus I. So I just had to get rid of all that there, and now I'm working on this complex number here. This is the complex number for question 15. Okay, so what we're going to get here is once again it's in the third quadrant. It's minus 1i here and root 3 here. Now we're going to start off by getting the r value. The r value once again is the square root of minus root 3 squared plus minus 1 squared. Put that into the calculator and we find out that it's going to be equal to 2. So our r value equals 2. Next thing we got to find out our reference number, tan r. Tan r is equal to 1 over root 3, opposite over adjacent, and that's going to be tan inverse 1 over root 3. So tan inverse 1 over root 3 and what we get here is equal to 30. So that equals 30 degrees. Now this 30 degrees is in the third quadrant, and for the third quadrant we do 180 plus 30, which makes an angle of 210. Finally, we're going to fit this to our generic formula, which is listed here. So we're going to get z equals 2 into cos 210 plus I sin 210. Okay, and that is the answer for number 15.